First we go to the body page and make a box. Let's set the dimensions to 1 in every axis. And go to the rest tab and just bring it up to 0.5 so that it's sitting on the ground. And now we go to the brain page and we make an output node and put TZ in it. Let's set the range to 10 and give it a value of about 3.6. And there goes. Okay, well, let's put a few of them in the scene. Go to the edit menu and get the place tool. We add a circle generator. Pump up the number a little bit. Set distance, angle variation, place. Okay, now all of our agents are obviously passing through each other. We'd like them to avoid each other, or avoid colliding at least. So we need to implement two rules. One is if left and near, turn right. The other is if right and near, turn left. Okay, so we're going to need some input data here, and we're going to use vision. So we know that these segments are called box 1. Each agent has one segment and it's called box 1. So we go box 1 colon vision dot x. That's going to get us the vision information. Really what it's telling us is the x value of each pixel in the image. Now what we're trying to do, we're trying to build these two rules. If left and near turn right, if right and near turn left. So we need to determine what our left and right inputs are. Now we're deriving them from this vision x value, but we need them as fuzzy inputs, fuzzy values. So we bring on two fuzz nodes and we connect our input node into them. We're going to call them left and right. Now one thing we forgot to do is set range to -1 to 1, because vision.x has a range of -1 to 1 and all of the range values are described in the channels page in the manual. Right, now if we look on here and if we set our agents going, we can actually see an indication of what these vision values map to. And if we go Alt-P, we can see what our currently selected agent can see there. This enables us to set our fuzz ranges of left and right. And we can actually see what it means. Okay, so now I'm creating our left fuzz membership curve, which just means this defines what left means in terms of the image. You don't have to be too precise with these values. And if I arrow up, it'll take me to the other fuzz node. You can arrow up and down through fuzz nodes that are connected to the same input. Okay, now we've determined what left and right are. So we're also going to need near. We've got left and right and we don't have near. Well, near is going to come from another vision input node. Box 1 colon vision dot z. And we just need one fuzz node because all we're trying to determine is near. Okay, so the z values are now mapped across our range here, and in this case the range is 0 to 1. Strangely, near is 1 and far is 0. So objects that are near to the agent will turn up on the right hand side, and if we hit the spacebar you can see a rather interesting image of what happens there. Okay, So we need to determine what near means. Well, let's pick an S-type membership function. Set it to about 0.95 on the right there, and about 0.7 on the left. And okay, so we've got left, right, and near. These are our fuzzy inputs that we need for our rules. Now, we're going to be controlling turning. Oops. So we bring on another output node, and we call it RY. We give it a range of -100 to 100. And let's just call the node turn, even though the channel is RY. Now we're going to plug in some defuzz nodes. So we're obviously going to need left and right, because we're going to need it to turn left and right. Oops. Left. And right. Okay. But some of the time we'll also want it to go straight, so we'll put that in there as well. Now we're ready to make our rules. So here's an AND node. We plug in left and near. Oops. We're plugging in left and near, and then we're going to connect that into right. So that says if left and near, turn right. Okay, let's get, well, first we'll give that a sensible label, just so that we can tell from a glance what's going on there. Now we bring on another AND node. This one's going to be if right and near, turn left. So we plug in right, and we plug in near, and we plug it into left. Right. Now the only thing missing is we haven't determined what left and right mean as far as the turn is concerned. So we have to give RY values for left and right. Okay, well, let's just drag to the extremes here. A left turn is a positive value for RY. A right turn is a negative value. And let's see what that gets us. Well, they are indeed turning away from each other, but they're still passing through each other, and there's a little bit of wobbliness going on, and that's because what we should have done is, since there's no inputs going into straight, and a lot of the time is not wanting to turn left or right, that means that the output value is undetermined because there's not enough information here. So what we need to do is just turn this into an else node. You should only do that for defuzz nodes that don't have any inputs. It just means that they're then the default value for that output. So we now have a default value of straight. That means that when left and right are not active, straight will be. Let's see if that's made any difference. Well, that's just made things a little bit smoother. But they're still passing through each other. What we need them to do is to slow down if they get too close to something in the center. So that's a new rule, and that rule is basically if center and near go slow. Okay, well, we're missing a couple of things here. We don't have center. Now that's going to be derived from vision X, just the same way that left and right are. So we create that one, and we can just middle drag the whole curve across here until it's in the middle, and that will do for center. Okay, we've got near, but we don't have any output values here of any use, so we'll make some. We need some defuzz nodes. At the very least we need slow, but we don't want it going slow all the time, so we're going to need normal as well. And we know that normal is not going to have anything plugged into it in this case. We're just going to make it an else. Okay, we bring on a rule, an end node, and we're going to call this center and near. We plug in center and near, and we plug that into slow. Well, slow's got a value of 0, which is fine. Normal should have a value of the speed that we were moving our engine at before, which was about 3.6. Okay, let's see what that does. Oh, that's much better. Now our agents are able to avoid collisions. and we can save our agent with